All right. Audio test. Bernard, can you hear me?
I can.
Great, and I can hear you. Perfect.
Okay, let's get started. This is the WebTrans Working Group meeting at IETF 111. Hopefully you're all in the right place. A few meeting tips. This session is being recorded. You're in here, you probably have done the data tracker login. The blue sheets are automatic. You can join the session Jabber room if you want to. Please use headphones or an echo canceling speakerphone, and please state your full name before speaking so we can accurately record that in the minutes. You enter the queue by pressing on the hand with the slash, and you leave it by pressing on the full hand. You need to enable your audio to be heard. People still learning that. And you unmute by pressing on the slashed microphone and disable by clicking on the mic. It's your choice whether to enable video. It's optional and is handled separately. Okay, this is the note well. Hopefully you all heard it a couple of times. By participating in the IETF, you agree to follow the processes, and those are described definitively in the documents, various BCPs.
Quick reminder, I just would like to highlight two important aspects of the note well. Most of you, if you've been here all week, have already seen it. But in case you haven't, one is the IETF's IPR policy. If you say anything there, it causes you to have to disclose patents you're personally aware of. Read the full details if you're not aware of this. And additionally is our code of conduct. We have been lucky to have a very well-running of respectful people at Web Transport. So let's keep it this way. And if you haven't looked at it, please take a look at the code of conduct as well. All right, thanks.
Thank you. We are looking for a note taker for the meeting. Do we have volunteers? We'd like you to take notes in the CodeMD, which we've provided. Anybody willing to volunteer to do that? Somebody must be willing to do it.
We will not be able to start this meeting unless we have a volunteer.
I can do it.
Who is that? Can you state your name?
Bishop.
Oh, Mike. Okay, thanks, Mike. And a Jabber scribe. Anybody willing to volunteer for that? Now that one probably isn't as essential, but Ali, can you be the Jabber scribe?
Well, I'm not on Jabber, but I can try to get on it.
Okay, thank you.
All right. We've been calling it Jabber, but there's it's hooked into Meet Echo. There's a chat there, so if you could just monitor, and if anyone asks for something to be relayed at the microphone, you could come and say it. So you don't need to install any Jabber client. Just having the Meet Echo, keeping an eye on the Meet Echo chat for folks asking to be relayed would be super helpful.
All right.
Yeah.
Thank you.
Thank you.
Thank you so much.
Okay, so here's the agenda. We have a few preliminaries. Then will give us the W3C update. Victor will talk about WebTrans over HTTP3. We'll have Eric talking about HTTP2. And then we'll wrap up and summarize. Any additions to the agenda or mods? Okay, so I'd like to hand it over to Will for the W3C web transport update.
Thank you, Bernard. Is audio okay?
Yeah, we're hearing you just fine.
Okay, good afternoon. Will Law Akamai, co-chair W3C, along with Yanni Var from Mozilla. So just some updates from the last time we presented this on May 20th, a couple of key decisions and PRs. We have defined a milestone for minimum viable ship. We do have a vendor who's indicated they're hoping to ship towards the end of the year. And while this doesn't specifically drive our timetable, we feel that a minimum viable collection of issues is good to go. We define a secure context for all the API surface. You'll only be able to access web transport under HTTPS. Definition of back pressure control attributes. Define a cleanup procedure around eventing, remove .state and on state change attributes. Also custom methods and promises for stop sending and reset stream. And very recently, over the last week, progress on a new web transport era. So the details of all of these are available on our GitHub page if anyone has further questions there. Next slide, please. Just a little summary, and this was at the prodding of Bernard to make this public. So AIO Quick, just by observation of 0915 and higher, now supports web transport. There's a demo server that runs a web transport echo server. And I believe this is going to be the basis for the web platform tests that will be developed for W3C. Small sample over to the right to show how it's accessed and how you get your data back. Luke at Twitch also indicated they've developed a closed source server implementation that implements web transport over HTTP3. If there are other servers available, we'd certainly like to hear about them on the W3C side and I believe also on the IETF side. We need to start promoting the accessibility and availability of these because it's only when you have a server and a client combination that a lot of the real testing can begin and also some of the use cases more fully explored. Chrome has signaled a Q4 release of web transport over H3. There's a link there to Chrome status updates. And also on the Blink side, an intent to experiment has a reasonably long thread. Mozilla are working on an implementation in Firefox, but have not provided dates to date. Next slide. There is a current flurry of video, specifically ingest, which just came out of that meeting, but other next-gen video protocols built directly on top of Quick. I list 3 here that are available. We believe it's in our mutual benefit that we start encouraging these projects to consider rebasing their implementations, if possible, on web transport. I know RT over Quick is not currently possible. We have a slide coming up on that. But they would inherit benefits such as automatic H2 fallback, which might be complex when you have to roll your own. You're getting the same bi- and unidirectional streams and datagram support with minimal code changes to your projects that you would get from raw Quick. And you're going to inherit a very large environment of browser implementations. And that's really useful in terms of reach and also testing and conformance. I noticed none of those prior projects mentioned web transport in their discussions today. So there's some mutual work to do here to encourage them to move over to the Web Transport camp. Next slide, please.
Yeah, so I just copied this.
I
just copied this over from Jorge's presentation, actually just a few minutes ago, and also from AVT Core. And I guess the question I'd have, and I don't think now's the time to follow up, but is there anything we need to do in Web Transport in the API, for example, to surface some of the stats that are being used in the RTP over QUIC, or potentially in the ACK area, which is currently not, there's no real info in the API. So that's more of a question for this and other implementations. Is there something missing in the API? And if so, can people speak up and maybe potentially address it? But I think this was a case where things were very tightly integrated, and it's not being surfaced. The info isn't being surfaced in the API currently.
Right, and just two more slides here from W3C, 2 requests to the IETF group. Firstly, to help clarify the prioritization of datagrams versus streams, and also streams versus streams. Is this going to be the responsibility of the user agent, or will there be core protocol assistance here? We have 2 issues open up on this for more background, and it would certainly help drive this towards the initial implementations are going to have to address this question. That's the first one. Next slide, please. On the second one, just an assistance on defining available error code spaces that the worker feels needs to be covered, as well as reserved error codes. So again, we have an issue open up on this that defines the exact questions, but we'd like some clarity from the IETF group, and I think both Victor, Bernard, and Yutaka can provide details on that. And those would be our 2 primary blockers at the moment. With that, Bernard, back to you. Thank you.
Thank you, Will. Okay, so we'd like to give the microphone to Victor to present Web Transport over HTTP 3.
So I would say, Bernard, if you stop presenting the slides, and then Victor will request them, and that way he can control the slides directly.
Okay. I will, let me see what I'll do. I will stop presenting them.
Yep, or actually, hold on. There, Grant, and there you go, Victor.
Do I just click share?
Yep, there you go. No, you don't need to. You already clicked on the slides, and you're good to go. We can see your slides, and now just go
I also
forward to
I wanted to open issues. Can I do that with slides?
Let's try again. Let's see if we can do both at the same time. If you
want to show them in GitHub, I think you'll need to do share the screen, right?
Yeah.
Oh, you can only do one at a time. So I guess we'll just have you share your screen then. Here you go.
Let's see. 1 second. Apparently, I need to grant like 100 permissions and enter my password. At least 100 times.
Yeah, this is the kind of thing we need to do before the session starts. Apologies, everyone.
Yeah. Okay, I can. Let's go back to 1 second. Where is the issues tab? Okay. Can you see the issues?
Yes.
Yep. It works.
We can. Cool.
Okay. Fortunately, I tagged all the issues that we need to discuss beforehand, so we can move straight into those. So issue number 10, I just wanted to make sure that we can close them. It's the one where we...
sorry, Victor, just to clarify based on what we were going to do, I thought you were going to give some updates on what's happened and run through those slides before we jump into issue resolution.
Oh, okay. Sure thing. Yeah, so okay, which slide is the Okay, so since last IETF, we actually released a new draft, draft 01. It has fixed 3 issues. One, we've decided that HTTPS is the correct scheme for our protocol. 2, we have agreed that we can use type value frames without length for the web transport frame, which is used to signal that the bidirectional stream is a web transport stream. And 3, we agreed to lift all of the requirements on waiting for handshake to finish before sending streams, which means now you can send data stream for a web transport session before you establish the connection. Before you establish that connect request, and similar, a server can wait before hearing back from client, and that way you don't have to wait for it, and you can start your connection faster. But it also means now you have to buffer your data streams to associate them with requests later. And there is a text about how to do that and how to time out streams. We've actually implemented all of that in Chrome. So draft 01 is the one currently available in Chrome. And at the interim, we discussed some issues, and there are PRs that everyone is welcome to look at. So issues, actually, this is where I would actually like to go through those issues in the list, because that's David, could you? People are welcome to not do that buffering. That would just result in I'm answering to Martin on Jabber. People are welcome to not do that buffering. It would result in they can reset the streams. But David? Datagrams, it's also an interesting case. Okay, so the issues are the first issue is issue number 10, and that's the one where we asked if we want to have consistent stream IDs between the client and the server. And I think at some point we decided that the answer is decidedly no, but I could not find that discussion. So I wanted to ask if people are okay with me just closing it, because we decided no in the past. Unless someone objects, I will just close it.
Okay, for the meeting minutes, please indicate that this issue has been closed.
Victor, just mention in there that that's what we plan on doing. We're going to give everyone a week to, if they weren't able to attend, and then just we'll go through a week from now and close all the issues if no one has commented.
Okay, sure. This is IETF 111, correct?
Yes.
Okay, good. Let's go. Next issue. The next issue is, let's start with the easier one. Reset stream. So reset streams, we had the problem where it is not always possible to associate those. And the solution is I wrote a PR that solves both this problem and reset stream error code problem. And the basic idea for that PR is where is the PR? Oh, I think the PR is attached to this issue. Here's the PR. So the proposal is basically, we are going to allocate 256 reset stream error codes, where 256 is a number that's small enough we can fit it both into H3 and H2 error space. And the idea is there is a allocation for those error codes, which is somewhat complicated because we have to omit Greece error points, but there is some nice pseudocode to show how to map those. But the idea is that by default, the web transport application error codes are best effort for resetting streams, because if you have pooling, it is possible the stream gets reset before you know which session it belongs to. The problem, and the only case in which we can actually provide reliable reset stream codes, and I think we should, is when you have no intermediaries and there is only one session, then you know it's a web transport reset stream error code, so you can just send it to the application. And that's the proposal. Do people have any opinions on this? Okay, do people... Martin?
This is the right solution. I think if you're going to try to make this reliable in the way that it would ensure that other sides get it, it wouldn't be reset stream anymore. And so I think this is the only sensible solution.
Okay, so does anyone else have any opinions? Because it sounds like we have an agreement that this is the correct way to go. All right, then. I would like Minus to reflect that that was the opinion, because there are actually two issues I would have to close. But I'd like to move on to the next issue for now, which is negotiation pooling support. So we had a long discussion about this in the past. And basically, the only thing people seem to agree is that we could do something like max web transport session option on the issue. So I would like to hear if people think that's an adequate solution, or that we should wait for, or we should go with some alternative. Because from discussion we had on the issue, it sounds like max web transport session is basically the right answer. Alan?
Yeah, I'm a little, I mean, I think I maybe even suggested that as an option, but it seems like the most complicated option. And I guess I'm comparing it to Mask, where Connect UDP opens a similar kind of session, but isn't throttled in any way, right? So I mean, maybe I'm comparing apples to oranges, or maybe not. But I mean, how critical is it that we limit this?
I guess from my perspective, it is not necessarily critical, but if we do want an option to limit it, we would probably want to add it before we add any kind of pooling. The reason I wanted to add it is because there are people who very explicitly said that they want only one session per connection. because that gives them opportunity to like have dedicated connection for every session because their application requires that. Martin.
Of those resource management problems that gets a little bit tricky once you talk about multiple of them on the same connection. And I tend to think that having some sort of control would be sensible. We don't have any other controls that sort of keep web transport from eating all of the things that HTTP has, but it's not that complicated. And I suspect that the right answer for mask is also a similar sort of control.
Thank you, Luke.
One of those people that doesn't want to have multiple web transport sessions. The reason why is we're using connection level stats to decide how much data to send over each session. So right now, if somebody tries to make a new web transport session, we just say no. Like if you try to make the second one on a connection, and it'd be great if there's some way to just tell the browser, dial a new quick connection, don't even bother doing this extra hop asking if it's allowed to or not.
All right, it sounds from what I hear is like people basically agree that max web transport session is just adequate. So how about I just write a pull request for that and we decide that that particular issue is solved? Does anyone object to that course of action? Alan?
I'm not sure I object, but I want to just clarify because the issue, I was just rereading it quickly. It talks about it's more not just a parameter max web transport sessions, which is the maximum number of concurrent allowed sessions, versus something that was more like, I'm going to use a dirty word here, HTTP3 push with like push ID, where you would say like max WT session ID, and then having to manage this more explicitly. So I just want to clarify what the proposal is.
Oh yeah, actually a question for you, Luke. Do you want one connection max simultaneously, or one connection on one session on connection simultaneously, or one session ever?
Yes.
You're muted. Okay, not muted anymore.
Yeah, for us it's simultaneous. We're using the congestion control statistics of the quick connection. So if nothing else is using it, then we're fine having a new one later and reusing.
Okay, and I assume you would actually benefit from like reusing the connection because you get to skip the slow start.
Yeah, then we don't have to do like zero RTT or anything.
Yeah, I think it's more of max concurrent connections than max connections ever. That sounds like that makes more sense, even though from the client perspective it's slightly different, but I think max web transport session equals 1 just makes sense. Alan?
In those, if you just say this is the number of concurrent sessions, do you then run into problems with like stop sendings and stuff where like one side they have a different idea of how many sessions are open?
Could you elaborate?
Having a hard time formulating the exact idea in my head, but like if are we saying like the client is the one that would always know how many sessions are open? But like what happens? The client has closed his session and then opens a new one, but that closing and opening is reordered. And so the server says, no, you can't do that. You already have a session open.
That is a good point. That is definitely something we would need to figure out. Could you note that issue on the GitHub? I think this is something we should just take offline further discussion because this gets into like deeper design problem. All right. I think we can move on. Like this issue, it sounds like we should figure out more details before we can close it. But let's move on to the next one. The next ones that I actually have tagged. Specify behavior when receiving a bad session ID. So there are multiple cases. One of them is very easy, and I wrote PR, is that all of your session IDs have to be client initiated by directional, and it's an error to use anything else. The second is more interesting. It is when you have a stream that is not the web transport stream, can you reset if someone tries to open a data stream for it? And the reason it's interesting is because there could be various race conditions. So I want to hear what people are saying about one, closing for all invalid all session IDs that are just a priori invalid. And two is, should we do anything more in terms of validation? Alan.
Yeah, I think for one, I think that it's fine. It's obvious if you're trying to create a session on a not client initiated bidirectional stream that should be probably a session error. ID error seems fine. And sorry, a connection error maybe is better than session. For two, I agree. There's race conditions where you may not know, but you can't maybe do anything with the session ID before you're worried about case. So like when the request arrives, if it's a get instead of an extended connect, and then later either a stream or a datagram tries to refer to that, you can tell that probably that it's not, that it's an open stream, but it's not a web transport session. So that's probably also a fatal error. If they were reordered and the stream arrived first, you kind of have to buffer it anyway. But maybe you're thinking, how do you distinguish it? But that's more about the buffering question. Anyway, I think I'm trying to say that we can do a little bit more than just one, but maybe I don't have a clear idea of exactly how much more.
Yeah, I think we can do two, but one thing that worries me about two is that like the conditions under which you can do two are very specific. And in case if you get one of the edge cases wrong, you will reset connection for valid reasons, and I don't want people to don't want to require this from everyone because this is just so easy to get wrong. Martin.
Yes, that the session ID is wrong, right? Number one, it's just obvious and it's intrinsic to the value, and you can just tell straight up. And so I think requiring that, and this is really just about discussing whether we require someone to generate a connection error or allowing to generate a connection error. So if you think about number one, I think it's totally reasonable to require it. That all I heard from number two is then maybe we can't require people generate a connection level error in this case, and we simply just have to allow them to create one. There's a lot of cases where this will be totally recognizable, and you've already had the get or something like that, then that's fine. But there are cases where the stream ID was long gone and you don't know whether it was a connect in the first place or a get, or maybe it's, I think the future one is easy because if you're buffering, but if you're not, then it's not easy. So I think this is just a may. And the third one, again, I don't know. If you never got the request, then it's completely unknowable. So
okay, so it sounds like for must close for one and may close in other sense. Does it sound right? Okay.
Just use the word sense of the room more than consensus in general. In general, we'll establish consensus on the list as per our usual process.
Okay. Sure. Let's move on to the next issue, which is this discussed last time. I actually wrote a pull request. I wanted to confirm that people are still okay with this and look at the pull request, but actually I'm not even going, like we discussed this last time, but I want to make sure that people know and look at the pull request. But basically, in order to negotiate versions via settings, the server has to wait until receiving settings from the client in order to, before processing any web transport requests. And that's because the wire protocol could change in between different versions. And in fact, if we cut the draft with all pending pull requests, it will change in incompatible manners. So that's not something I feel we need to have another discussion. You're welcome to comment on the PR and the issue. The next one is we discussed in tandem with the other resistream issues that we allocated 256 resistream error codes, and you're welcome to take a look at the pull request and comment on it and comment on the issue if you think our approach should be different. So I'll move on to the next issue, which is actually really interesting, which is error codes for closing the session. This is roughly the idea that in Quick we have something like connection close, and that gives you an error code and an error string, and it would be nice to have that in web transport over HTTP free as well. So I wrote up a pull request for this, which last time we did not have a specific mechanism, but this uses the HTTP capsule, which will probably be going over web transport data connect stream data frames, judging by how the discussion went in Mask on Monday. But it provides a capsule with this specific format. Do people have any opinions or objections on this proposal? Alan.
Do you also need something like the go away stream IDs so that the peer knows like what the last thing was that you got, to help for cases where the protocol that's running on top of web transport wants to drain in a more graceful way? Or is that a separate capsule that we would introduce?
That is probably a separate capsule, because nominal connection close just implies that everything else goes away. And that is fine for the error case, the case when you have a connection error. For go away, there is a separate issue, which I think we might also get to discuss at this if we have enough time. Yeah, if you have specific comments about like the fact that I accidentally specified number of bytes instead of bits, you're welcome to comment on the pull request. Lucas.
Can you hear me?
We can hear you.
Good. Yeah, I took a brief look at this PR, then I saw it was using capsules, and I got depressed from the other day with the capsule stuff. I think like the content of the capsule is the important thing here. And I saw David made some comments on the PR about bits and blah, blah, blah. But the one that I would have also made is about the application error message. Like, I was trying to understand, is this closed session more similar to like the quick connection close frame, or is it more similar to the stream reset? And And like, I wanted just to understand the motivation for that error message. Like, who's asking for that? Who's going to use it and what for?
The idea was to provide facilities similar to connection close in Quick, and the reason is sometimes your application protocol on top of Web Transport would want to signal that, but it would also want to close the connection, and provides a way to signal it and then let the Web Transport stack deal with actually terminating the session.
Mm-hmm. Cool. I haven't got a strong opinion either way. I just wanted some clarification. So I think that helps a bit. So thank you, Victor.
Thank you. All right, David.
Sorry, waiting for the microphone to start. Just wanted to quickly clarify one thing that Lucas was saying about capsules. Is we're in Mask in the process of changing the encoding of capsules, but I haven't heard anything to the lines of us kind of removing them. So the fact that this PR uses capsules is perfectly fine. We're, at least from that perspective, and we're going to work on exactly how they're sent over there. But it's looking like capsules are here to stay in Mask. Just wanted to make sure everyone was on the same page.
Thank you for clarification. People are welcome to read this PR more closely. I think, unless anyone has objections to like the general idea of having a capsule for that, I would like to move on to next issue. So does anyone want to speak against the general idea of having closed Web Transport session? All right, let's move on to the next issue then. This is another issue we discussed at the previous meeting, and I wrote a PR, and I just wanted to point out that this PR exists and everyone should take a look. Web Transport currently requires status code 200 for creating a connection, and general HTTP free internet draft requires you to have any of 2xx error codes, so 200 to 299. And this basically brings us with alignment with what HTTP free requires for generic connect, because that just makes sense to stay consistent. Martin, the answer is the current, to your question on Jabber, the current requirement is to send the fin after the capsule and everything else is an error. So there is some disagreement in the discussion. All right, I pointed out this exists. The next one is an issue that should have a PR, but it doesn't. I wanted to reconfirm that we're still okay with that, because otherwise I will go and write this PR and list it as other issues. Is that we want to make sure that we want to make Web Transport stream unidirectional look the same way, framed the same way they're framed as bidirectional, which is to say, currently we have this, and the idea is to make it a stream of frames. And that would use the existing frame for bidirectional streams, as that would bring it with alignment with everything else in HTTP free. We discussed this as previous meeting. I just want to point out that there will be a PR, and unless anyone objects, the PR will go into the next version of the draft. So if you object, please comment on this issue. The next issue is connection throttling. So WebSockets had some text about throttling connections and how many you can have concurrently. We should probably talk about that, and it is unclear entirely to me whether we should talk this in this draft or leave it in W3C or somewhere else, because this is as much of like browser issue, but as it is a protocol issue. But there are roughly, what makes this specifically tricky is that in some cases, WebTransport may be requested as a non-pool dedicated connections. And in general, if your connections are pooled, you don't care as much, and you can refuse streams. But if they aren't, that means you can spam handshakes and create too many connections from one browser. And the question I would like to ask is even less of what should we write text, because I think the text here is like fairly obvious. You should limit the number of connections, but whether we should write text in the protocol draft or we should defer to the upper layer at the API. What do people think? Yes, Martin, that's a good. That's effectively what I'm asking. Who should limit connections, and when? Everyone is a possible answer, but the question here is every client, presumably, because it definitely the servers are. It is less relevant on servers because servers don't create outcome connections. But the question would be, if we decide that every client should limit outgoing connections, we could write that in the draft. But if we decide that this is not a problem with most clients and only problems with clients that run inside browsers, which means they're untrusted, that's a different issue. So that's primarily the question I'm interested in being answered here. It doesn't look like people have any opinions, or seems like, as Martin says, seems like this needs further study. Possibly. It sounds like no one wants to say anything at the mic, so I will write those proposals and pick a default one, and like, if no one objects, I would go with that. But it doesn't sound like anyone wants to say anything in this meeting. So, oh, Martin, yeah.
Work out how you would even think about this problem, but it seems to me like saying nothing would be what I would start with here, and servers that do have this problem will need to manage it. Browsers will probably have to manage this as well. You probably don't want to dedicate infinite resources to a single site, or allow sites to create multiple frames and thousands of connections. But these are things that each can independently work through. At most, at this point, I think, yeah, David said may throttle. I think that just some security considerations text or something along those lines that basically says that connections aren't free. Consider limiting them, either at the server or at the client, then that would be fine. No mechanisms.
So that makes sense. My intuition would be that like the main text that would need discuss throttling is probably actually W3C, since browsers are in the position where they're most likely to have a client maliciously open too many connections.
That's probably true. But at the same time, it's not something that we can necessarily provide in APIs or anything like that. We just have to deny access to these things arbitrarily, probably, from the perspective of the people using it, the API.
I agree with that. So it sounds like this needs further discussion on the issue. So I'll move on to the next issue, which is the most fun issue, definitely. And it's titled, "What should we do with datagram context IDs?" So for some context, so the H3 datagram draft provides with two ways to use datagrams associated with a specific stream. One is you send a capsule called register datagram no context, and you have no context whatsoever. You still have to send that capsule to let the peer know that that's how you're using it, but otherwise you don't have any context. You care about context after that. And the second one is it can send a register context, which provides you with the context IDs, and it also has an extension field which defines what exactly is supposed to go in that context. And the question here is, do we want to support context in general, or do we want to only use no context of web transport and make register any context an error? So I think that's a rough summary. David?
Okay, sorry, always waiting for the microphone thing to get over this Meet Echo bug. So just to clarify on the wording, so speaking not as Web Transport Chair, but as the author of the HTTP3 datagram document, the mindset in that document isn't that it's context or no context. It's like there's always a context, but when you register no context, what it means, you still kind of negotiate the format for that context. It's just that you have one for the entire connection. You no longer have a context ID that allows you to multiplex multiple contexts. And one of the important distinctions there is that you can kind of saying, I register no context and just use that is, from the higher level perspective, the exact same thing as saying I register context 2, for example, with that format and only use that one. Like they're completely semantically the same. It's just on the wire encoding, you end up with an extra variant that gets sent around. And so at least in the mindset of the current HTTP datagrams document, the idea is that you'll, for example, the way I would see this playing out is for Web Transport to say, well, we're currently only using one context. You should use the register no context frame to save that byte, but we shouldn't preclude anything else because we could imagine using more inside Web Transport later for extensions.
All right, thank you, Martin.
So David's suggestion here is reasonable. If you think that extensions of that shape are possible. And this is probably something that's hard to know at this point. I mean, I can't imagine any way in which we could use the API that we have to build multiple contexts. And so that makes me a little sort of cautious about using this mechanism. I would probably lean towards saying that no use of the context mechanism is made of this, and then leave it at that. You don't actually have to send either of these frames, do you, David?
The way the HTTP datagrams draft is currently written, the client has to send at least one of these frames, one of these register context frames, before it starts using datagrams, because that's how it communicates to the server that there is a context ID or not inside the datagram frame.
Yeah, so maybe I need to take this to mask, but I'm starting to reach the conclusion that this context ID thing isn't actually useful.
So we have some uses there. So I mean, yeah, we could definitely take that to mask command. But one example, just that is specific to web transport, could be if we want to do priorities at some point down the line, where you would say like the usual context that is being defined in this spec is the regular default priority, but later down the road you could say, okay, I'm registering context 14, and that one is for background datagrams that should be prioritized lower. For example, I don't know if that extension is a good idea, but that could be a usage for web transport at some point.
Yeah, that sounds like a not useful use of the mechanism. Here I'm thinking more though that that we have no way to expose these in the API at all. And so the concept doesn't really make any sense for the application.
So sorry, can you clarify?
To see what
API? Do you mean the W3C API or the like API between HTTP datagrams and web transport?
I'm talking about the one that's exposed to the applications that use web transport. So yes, the W3C API or whatever API you're building on the server.
Absolutely. And so saying we're only going to use like a single context there is the right way to go, because you're right, it's not going to show up in W3C. The only thing that I kind of objected to was option 1 that Victor mentioned here, which was to say that web transport servers could only implement half or a partial implementation of the HTTP datagrams document, and that was what was making me concerned, because it could prevent us from doing extensions later.
Just a warning, we're have only a couple of minutes left in this session, so I think we need to speed things up.
I mean, this is the main issue I wanted to discuss. That's probably the most tricky one. Eric Kinnear.
Yeah, I was just curious, actually, Martin Thompson, kind of about some of the reasoning for why the flow ID isn't useful, because are you saying effectively that it's not that priorities or something else isn't an interesting use case, but that any of those use cases would have to come along with some signaling at the application layer, which means that at that point you might as well just accept the fact that we're going to have kind of this duplicative, you know, this particular variant or this particular section of a datagram is the ID for whatever. Tying that to the application and the thing that it actually uses means that it's not worth having something at a lower layer that is common, or is it on a totally different tech?
So there will be applications that need contexts. There are applications that won't, and this is one of those applications that I think doesn't. And I'm sort of wondering why there's even a generic mechanism. I think there's probably some value in having some signaling that says, yes, I'm using datagrams, but that's the signaling that we want to use, not here's this generic mechanism that will sort of get in the way in a lot of cases. And it goes back to the datagram debate about having context IDs at the datagram layer.
Gotcha.
It's a one-size-fits-all solution, which means that it's
So speaking as web transport chair, I'm going to say that this is a part of the HTTP datagrams document. So let's take this to mask. Let's discuss this on the HTTP datagrams draft. And then now speaking kind of personally, I would say that web transport should not allow like half implementing the HTTP datagrams document. So if you think that there is a part of it that shouldn't be in it, let's take that discussion to mask and go see how we want HTTP datagrams to look like. And then web transport will use those and will like implement all the mandatory to implement parts of HTTP datagrams. That still can be changed. That's still an active discussion in mask, but maybe we put a pin in this for today's session, given the time, and we'll discuss it in mask with all the mask enthusiasts.
I will say that I'm personally actually agree with that, and it is more like option 1 is more of was attempt to do that given what H3 datagram says, but the best way to rephrase option 1 would be just like we don't need contexts, and that is a valid opinion, and I personally more inclined to agree with that. That web transport doesn't need context in general, but that is in fact better suited for Mask working group. Now, I think we discussed almost all of issues except the one with go away, which I left as complicated. How much time do we have left? I assume we don't have any for this presentation.
Yes, we are out of time
That's
to be.
repeated.
Oh, okay. I'll with couple finishing remarks before I go, which is basically roughly, please go to the issues. Please read all of the pull requests. I will ask the shares if we can have a consensus call for all of those. But there are PRs, and I strongly encourage people to look at them. That's it for me.
Okay, so next on the agenda, I guess we have Eric. How do you want to do the slides?
Sent a request to share them. All right. You should be able to see slides. All right, so we have kind of two major things to talk about today. Since the previous IETF, we've adopted web transport over HTTP2 and incorporated a couple of different pull requests and things. And so I think we're trying to kind of pull that into a more cohesive look here, especially given the conversation that we were having on the list that Martin Thompson started, which has been super illuminating so far. So fundamentally, the thing that we're trying to do with web transport over HTTP2 is provide a mapping that can run on top of TCP when HTTP3 and underneath it Quick aren't available. And so we want to be able to handle the case where, hey, you know, Quick is blocked on this particular enterprise network or whatever's going on, and I would like people there to still be able to talk to my web transport server and use whatever my application that depends on web transport is. And in order to do this, we built web transport over H2 kind of very similarly to H3 because we want to have many of the same capabilities. And the point was raised that there's some interesting layering questions that brings up that aren't necessarily present in the way we do H3. So I tried to draw a picture. It may or may not be helpful, but I'm trying to find a good way to visualize what this difference is and see what's going on as we talk about, are we kind of integrating into HTTP2 or are we building on top of HTTP2? So web transport, when it's over H3, does a couple of things here. So on this slide, we have kind of unidirectional streams that you can open. We have bidirectional streams that you can open. And there's new HTTP3 frames that are created and potentially last until the end of the stream. For, you know, web transport stream, which I've abbreviated to WT stream here. And you can also send HTTP3 datagrams, which is what we were just talking about. And those end up getting mapped onto Quick datagrams, Quick bidirectional streams, Quick unidirectional streams. Underneath that, I've put separate UDP kind of packets for each one, because part of the reason that we do this and part of the reason that we don't just send all of the different web transport streams over a single Quick stream is because we want that independence. We want the ability to map directly onto Quick streams so that we can have a lot of the benefits that we get from Quick in removing some of that head of line blocking and all of those things. And yes, indeed, Mike. When we do that over H2, it gets a little bit more interesting because, of course, one of the big questions about H2 is that you now are running this on top of TLS, on top of TCP, and H2 is doing a lot of this multiplexing into a single ordered byte stream. And normally, H2 does this by, you know, you send a headers frame and then you send data frames, and that's all great and fun and everything. But we've got these web transport things up at the top, like we want to be able to send datagrams. And we need to have bidirectional streams, which H2 has, but we also need those bidirectional streams to be able to be initiated by the server, which H2 doesn't have. Similarly, we want unidirectional streams. So in order to do this, we end up introducing a couple of new frames to HTTP2. And so we end up sending datagrams over a WT datagram frame in H2, for which we've defined the semantics to be fairly similar to an H3 datagram. We introduce a new WT stream frame, which the server can send or the client can send, and it's kind of semantically equivalent to a headers frame, but can be initiated by the server. And then, we can do a couple of fun options and things on that to make unistreams work and all that sort of thing of basically, hey, start this half closed and everything's happy. Now you have a unidirectional stream. But conceptually, what we've done here is we've, use the language that Martin did in his email, we've effectively integrated this into H2. So we've added new frames to H2, which means that if you want to support this, you need to change your HTTP2 implementation, not just have an HTTP2 implementation that you can build on top of. And that might be fine. Looking at this, what we actually ended up doing was defining 4 new H2 frames. And so we did that with WT datagram stream. Those are kind of the main ones. And then there's a reset stream and a stop sending. And that kind of goes along with the way that we want to be able to, half close a stream where in H2, resetting the stream tears the entire stream down. So we're effectively adding those final 2 frames to bring, and even really the first 2, to bring HTTP3 semantics and capabilities over to H2. Right now, when we talk about that being integrated, we're saying we're adding new frames to H2 and you have to update your H2 implementation to be able to handle those new frame types, which is good. We have an extension mechanism for HTTP2. This would be a great way to use that extension mechanism, really exercise that, and that would be great. But one of the alternatives that was brought up is, should WebTransport, when it's running over H2, be layered on top of H2? So effectively, what that would mean is that I can take any off-the-shelf HTTP2 stack, or even potentially HTTP1, which we'll talk about in a little bit, to implement WebTransport. And that effectively means, do we send our extended connect? Do we say, hey, I'm connecting for WebTransport? That gets everybody's happy. Now I've got a HTTP2 stream. Do I then mux and demux all of my different WebTransport streams onto that single HTTP2 stream? And from there, you can kind of break things out into a kind of native mapping. If you wanted to have separate H2 streams per WebTransport stream, you could do that, but not if they're server initiated, or you'd have to have the server signal about that, or not if they're unidirectional and datagrams are fun and exciting. So in order to do this, one way to do that mux and demux of WebTransport frames is, or of WebTransport streams, is to effectively bring many of the things that Quick Transport provides over to TCP. And so I let the list kind of run off the screen here because I don't think it's actually a fair comparison if we just say, hey, on one side we have to define 4 new frames and on the other side we have to define a whole bunch. I think the actual comparison ends up looking kind of like this. And so we have WebTransport datagram you need to add, or if you're effectively using Quick with all of the semantics that already work underneath H3 and everything, you end up with bringing over a datagram frame. You bring over stream frames. You just use stream frames on top of that H2 stream that you already have. We need to bring over reset stream and stop sending. That's great. They can be very clean. You've got all the same semantics that you were expecting from WebTransport over H3. Generally works exactly the same way. And then the other streams that you need to bring over are mostly flow control. So you have max data, max streams, all that sort of thing. But conceptually, that's something that we were previously getting from H2. So I think that's one of the major differentiators between these two approaches. There's not actually that much more that you need to bring over. So you bring over this flow control, sure, you bring over padding, that's fine. But fundamentally, you have datagram, you have stream, and now you're sitting on top of H2. You can use H2 off the shelf, and you have kind of one-to-one semantics with what you were expecting from web transport over H3. With that in mind, issue number 25 in GitHub is currently about datagrams and how we send datagrams over H2 and kind of where the H3 datagram is and all the capsule stuff is going in mask. And the proposal here is we should use whatever approach to doing this that we have coming out of whatever mask decides. And since the mask meeting on Monday, that effectively means a layered approach where the body of the connect stream that you use is a sequence of capsules that end up being conveyed in data frames. And you define a datagram capsule that carries one of these datagrams. And so you can still transport all of these things, but you're doing it using a capsule rather than defining a new frame that's handling all of it. That then brings up an interesting question about streams. So we could have the capsule over the message body kind of going in the data frames be used as a fallback when you don't have something natively. So this is where we start talking about, well, if we're doing this kind of quick mapping over this H2 stream, do we have the ability to split out some of these concepts to whatever the native underlying transports construct is? So in theory, if I have H3 datagrams that are going over H3 and I want to send a web transport datagram, well, then that's great. We've got a native construct all the way down to the wire for a datagram when I'm using H3. I can use an H3 datagram, which is then sent inside of a quick datagram, which is then sent inside of a UDP packet. If I'm going over H2, I don't have that. And so I can define a capsule that takes my web transport datagram, send that inside of my capsule over a regular stream in H2 that gets transported to the other side and then can be used in a similar way. We've already coped with a lot of the kind of implications of that in terms of head of line blocking and that sort of thing, no matter what we do with web transport over H2. But if we take that same philosophy and apply it to streams, HTTP2 provides native streams. So one of the big questions here is, should web transport streams, if we go this route, end up splitting out to use native HTTP2 streams? And perhaps if you're going over H1, you don't have native streams, and so you would end up inside capsules for everything. Speaking of H1, there's a bunch of questions that we're raising here, and then we've got kind of some time for discussion at the end. Do we think that it's interesting to support H1? Is that a requirement? Is that something that we have use for? If we're taking the approach of augmenting H2 with new kind of native H2 frames, rather than laying it on top of H2, then obviously that doesn't directly translate over to H1. But if we have something that is layered on top of H2, then it's not a super large leap to go from that to talking about doing this over H1. The second question here is basically, is proxying through a generic H2 intermediary requirement? And that comes into play with a lot of the questions around capsules being end-to-end, and how do we handle all of these different situations where when you have an intermediary, the underlying transport might change. So I could be doing H3 and breaking out my datagrams to actual datagrams, but then if I go and I end up walking through somewhere that's H2 or even H1, do we need to have the flexibility to be able to go in and out there? I see Bernard has joined the queue.
I just wanted to comment that I think it's important to keep in mind where things are deployed in terms of the answering these questions. And my experience is in the enterprise, if you're talking about HTTP1, you're talking about a pretty old box, which might not be upgradable to do almost anything new, which is why I suspect my personal view is that HTTP1 is not a requirement, but I'd like to hear what others think.
I could see that. let's keep walking through the next couple of pieces here so we can do a little bit of comparison, and then we'll see if there's some thoughts on kind of where we want to go with some of these things. So looking at the differences between these kinds of things, there's one area of difference, which is kind of the end-to-endness versus the hop-by-hopness. So a native stream is going to be hop-by-hop. So if we're using a native stream, or we've broken things out to use kind of the native capabilities of the underlying transport, all of those things are kind of inherently hop-by-hop, similar to how WebTransport over H3 is using quick streams. When we look at unidirectionality, H2 does not natively come with unidirectional streams, and so we've added those as an extension, which needs a couple of minor tweaks, and that kind of snowballs into a couple of other considerations you have to deal with, and that's where we ended up with some of the additional frames there. And so that's where we look at things like the unidirectional ability to reset a bidirectional stream and kind of half close it. That's another thing that's added as an extension. And so I don't think the current draft is claiming that everything works natively one-to-one with the way H2 works, which is a fallout from the fact that we did not keep H3 and H2 looking exactly the same way. So we're effectively bringing a lot of the H3 shape of things over to H2. And one of the questions that I think we need to answer here is, how much work is that? And is it different from bringing something that lives on top of H2 and can just expose the semantics that we're expecting directly? When we look at resource management, there's a couple of interesting questions here. So there's flow control and stream limits. And if that already pretty much does what we want for WebTransport, then that's great, because we don't have to bring over all the new frames and everything to do flow control. And we don't have to re-implement flow control because our H2 implementation already has flow control that generally works. Obviously, the corollary to that is, if the flow control and limits that we have for H2 don't match what we want, then we have to build them anyway. Going along with that, there's a question here about kind of session state management. If you're layered on top of H2, and each new H2 stream that you open is effectively a new WebTransport session, then we've got great stream limits in H2 that are built in that kind of manage that state and control how many of those you can open. That, of course, gets more complicated if you then break out to use native H2 streams and all that sort of thing. So I think when we talk about session state management, we're going to have to do some work no matter what. The question is where. When we look at pros and cons of these, one option is, if we build WebTransport over that single stream and we put new things on top, that potentially requires more effort than you would otherwise, because you have to do new stream management. You have to bring flow control. You have to implement all of the flow control. You have to do all of the mucks and demucks of everything. However, there's a big assumption there, which is that that's more effort assuming that you started with an H2 stack. And so if you're not starting with an H2 stack that you can modify, then maybe that isn't more effort, because you'd otherwise have to bring the entirety of H2 with you. On the flip side of that, if you're doing kind of the layered approach, that is really interesting, in part because it works over H1, which may or may not be a goal. So that's one of the things that we'd like to kind of settle on ideally in the next day or a couple of weeks. It's end-to-end by design, because I've got this stream that I've opened to the other endpoint, and whatever I'm muxing and demuxing over it is up to me how much I choose to kind of split out to whatever the native transport is doing. And it could also be reusable in other contexts where quick is not available. So we were talking at the very beginning of this WebTransport session, and we were discussing some of the other people who wanted to do, you know, video over quick and some of the other protocols, and saying, hey, maybe they should use WebTransport. And so one of the big questions here, as we look at what's going on, is, do we have additional use cases here for this other thing that is ostensibly using quick or H3 that needs to run over TCP? Personally, and this is my own personal opinion, there is a difference in the result of the equation if the question being asked is, for WebTransport alone, should I rebuild much of quick and what quick provides, over an H2 stream and then never use it again, when I could just take my existing H2 that has most of it and strap 4 extra frames on the side and generally be in good shape, versus I've got these 4 or 5 different things for which I'm going to need a fallback for when quick isn't available. And if I build this mapping of effectively quick over TLS, TCP, etc., I can use it for web transport, and I can also use it for other things. So this is where we start talking about layering. Do we do what we talked about at the beginning of the meeting and ask all of them to go and build everything that they're doing on top of web transport? Or do we say, hey, let's build this other thing that lives somewhere and build web transport and all of those other use cases on top of it? And we'll talk about Connect in a little bit. So that is kind of the key question, I think, for right now. What do we think? What do we want to do? We'd love some input. I see Martin is in the queue.
Interesting, it works. So I'm not sure that this is quite the framing that I would have used, but it's pretty close. What I found interesting was the discussion we had in Mask about this, where we effectively decided there to, rather than layer on top of a version-specific protocol, so we're not strictly layered on top of HTTP3, we're layered on top of HTTP, and then we opportunistically use the native capabilities of the transport when they are available. I think that's the right way of thinking about how to build these things, because then you have a baseline that works and can be comprehensible, and you then opportunistically upgrade into those things. I don't want to spend a whole lot of effort on HTTP2 implementations here. I want to have an implementation that is as close to zero as possible, and integrating with H2 and modifying the stream state machines is a problem for me, far more so than having to, as Alan says, re-implement the flow control piece, because the flow control piece in Quick is relatively simple. The tuning of it is not, but it is relatively simple to get the flow control piece right. And it's not that much code in Rust, and I can't imagine it being too much more code in languages that are less good. But so I'd like to concentrate on that as the framing for this one, which is, are we building on top of HTTP, where we get some end-to-end guarantees, and it will work across any version. Whether or not we care about that, I think becomes almost irrelevant at that point. And then we can talk about opportunistically using those capabilities. That might result in us re-examining how we structure documents and whatnot, but that's, those people who write specifications are the least important in any of these considerations anyway. So I prefer to see it that way.
I think that makes a lot of sense. The key question that I'm hearing there is effectively, is it more work or more painful to redo flow control? Speaking as somebody who has had a bunch of various bugs and kinks to work out in Quick's flow control as well as H2. But vice versa, can we do that everywhere on top of HTTP? Ian.
Thanks. So I have a fairly strong opinion that I would really like to support this over HTTP1. I have experiences with protocols that are designed to tightly integrate with HTTP2, gRPC, and there have been some challenges there, in particular, like the hard dependency on trailers and things like this, like that make it it makes it much more difficult to deploy in a general purpose proxy and so on and so forth. So I would say, based on my experience, like anything that smells of that, like I would be very hesitant to do. But also I think going over H1 for an application like web transport, if you're going over TCP anyway, is like fine. Like there's no real meaningful performance difference I would anticipate. The other thing is I think the quick over reliable stream or quick over TCP or whatever you want to call this, I think there's a there. Like I think we've kind of tossed this around before, and weirdly enough, I just dug up a design doc I wrote like a year and a half ago about this that was called Quick over TCP. And I don't know if it says it's half baked, so I suspect it's half baked. But I think this has real use cases that could be very valuable. And then the final point I was going to add is, like, yes, I have an HTTP2 stack, so like it seems really convenient to use that. But like at this point, doesn't everyone already have like an HTTP3 stack as well? So like, sure, I don't have to rewrite the flow controller because I can just use the one from my HTTP3 stack. So if HTTP3 wasn't already so widely deployed, I would say like, oh, maybe this is like onerous. But if we can reuse a lot of the functionality, I think it puts us in a better place. And it's certainly much better for like multi-layer proxies. Thanks.
Makes a lot of sense. If you were doing Quick over TCP, would you also do H3 over TCP?
The way not the way I have it documented. No, that would be unnecessary. It would just be the quick transport layer without you like remove the acknowledgements, and I can't remember. There are a few other bits that you get to remove, but it's mostly the ACKs, I think.
Yeah, thank you.
You're welcome.
Victor.
Yeah, I also find the idea of not trying to completely modify HTTP to state machine to what we want more appealing. But my old answer to that was like, we should just use HTTP to state machine and port that to web transport over HTTP3. And I'm less enthusiastic about that now than I was before. One thing I want to point out is that if you go back to the very old presentations on what web transport should be, it had 4 protocols, and it always had like the quick transport, H3 transport, H2 transport, and the thing that I never created, which was called Fallback Transport, and which is basically this proposal of independent framing, but it was, instead of running directly over connect stream, it used WebSocket messages. And there were multiple reasons we wanted that, one of which was that already exists, and that's what everyone knows how to deal with. And you could even deploy it in browsers like today. But that never really advanced because there didn't seem to be a lot of practical interest, as in, when I say practical interest, all people who wanted a TCP fallback were more enthusiastic about HTTP2. But now that we're looking into all of the details of how to layer it, that option sounds progressively more and more appealing.
So that's interesting, because I think there's a difference between what we're talking about here and whether we're talking about H3 transport versus quick transport and H2 transport versus fallback transport. The difference being, my understanding at the time is we said, hey, we want to build web transport on top of HTTP because otherwise we're going to be bringing our own, I need effectively structured metadata that I can send as part of these messages that's, that I want to define where it goes and how that all works. So I think what we're talking about right now is effectively providing this on top of HTTP rather than removing the HTTP parts of it. But yes, I do think the fact that those exist and are probably viable means that this is also probably viable for many of the same reasons.
What I wanted, well, when you say headers, you mean headers for streams inside web transport? Or for like outside of it? Because the one thing is that older HTTP3 transport proposal is that it had a headers not only for the connect stream, but also for every data stream. And we never ended up implementing that because it's just a lot of complexity, especially given that headers have semantics that intermediaries and servers can misinterpret, etc. I agree that we should not remove HTTP, but I want to point out that this idea existed before, and it was not discarded because we thought it was bad. It was discarded because there was no interest in it.
Makes a lot of sense. Luke looks like he's next.
Just wanted to speak up as well as one of the video over quick folks too. Generally what we have is some legacy TCP systems, either HTTP 1.1 or HTTP2 or RTMP on the video side that all suffer from head-of-line blocking. And I think the main compelling use case for web transport is we want to get rid of that. And we get that for 95% of people, right, if UDP is enabled. And then it really comes down to, like, what's the least amount of resistance to get support for that remaining 5% of people that are stuck on TCP. So I think it's pretty important to make any solution relatively simple, ideally layered on something existing. I don't want to like rewrite my HTTP2 server. It just seems like that's a lot of effort for very little benefit. So that's my take, is it just, as much as we can simplify this TCP layer, maybe go over WebSockets or something, just to layer it on top of existing software.
Makes sense. There's a certain amount of, I think a lot of the question that we're facing right now is about how much effort it is to do one way versus the other, right? How hard is it to bolt a little bit into your existing H2 server, or the alternative there being, hey, I'd like to build this entirely complete, new thing, but it's on top of that H2 server, so maybe I don't even have to crack it open at all, which could be very attractive. That also brings up potentially a set of additional use cases for other things over QUIC that would like a fallback like this, that would potentially like to not have to define a fallback for each one of those things. Alan.
Yeah, I guess one thing I wanted to hear more about, I guess, is the similarity of resource management to, like, is H2's built-in resource management even apt for what the resource management will be for web transport? And I thought we would spend more time in H3 talking about, for example, do we need a stream limit per session that is different than the global stream limit on the connection? Or do we want a session level flow control parameter which is different from the connection level flow control parameter? And both of those things, depending on the decisions on the sort of higher level, what do we want to do with web transport for our primary transport, would help inform this discussion somewhat, which is like, if what H2 has baked in isn't even adequate, there's even less attraction in retaining it at all. I mean, I've obviously heard a number of people, I may be the only person who enjoys tinkering with my H2 stack occasionally, but I hear a lot of people saying, like, they don't want to touch it at all, and that's real. I think, and the way Martin has framed it too, about upgrading to native capabilities where available, I mean, building this over H1 or over, any generic in-order byte stream, basically QUIC over a single byte stream, could be a place to start. And then, there could potentially be, if somebody wanted to have the H2 version of it use some native H2 streams because they are apt, that could be an option. But I don't know, it sounds like I hear a lot more appetite for people wanting to implement quick streams over a single byte stream than for tinkering with H2 stacks.
I think that kind of matches what I'm hearing as well. Victor?
Yes, the reason we've not discussed that many issues related to resource management in H3 was that at some point we made decisions that we will solve the issues not related to pooling first, because the first version, at least we intend to ship, is like non-pooled, and then we will move to pooling support. The one thing I wanted to point out is that the TCP fallback is not only for people who have UDP blocked. There are a lot of scenarios where you would just want to use TCP, like inside data centers, where your TCP stack is heavily integrated with OS and optimized, or if you're, let's say, a cloud service which does load balancer for your cloud users, you would like it to handle terminating quick for you and then connect with something that's probably going to be HTTP 1 or 2, because that's what people tend to use for like load balancer to server use case. So this is much broader than just the 5% of users who do not have UDP available on their network.
Thanks. Yeah, that's really good to keep in mind. So I'm hearing a lot of support for the idea of effectively layering this on top of H2 rather than inside of H2. In practical considerations here, are there any folks who would be willing to kind of implement that and do it if we started writing it up? Yes, that's a good point. It's on top of HTTP rather than HTTP2 specifically. So I think that an easy next step there is write that up and get it going. Are there folks who would be willing to implement so that we can start doing that? Alan?
Yeah, I mean, I think the first step would be to produce a document that describes, what such a thing would look like. I know Martin sort of took an early stab at it, but I think we probably need to fill in the details there. Once such a document was available, the next hackathon around, like, I would consider doing it. And I think as someone who has already implemented something very similar to what the existing H2 draft is, I think it would be illustrative to me to have implemented both systems. Although I definitely hear in the room that I don't think anybody cares if it's easier to do over H2. Nobody wants to touch it no matter what, even if it was one line change. So maybe the effort level is just not a factor. And the other advantages, being able to go through an intermediary that's never seen this extension, being able to work over HTTP 1.1 are both much more compelling. So it seems like that's probably the direction we want to go.
It's interesting. So for context, we've shipped a previous iteration of one of these things, and it ended up being a 4 or 5 line change in our H2 stack to make it work for both the client and the server. But that was not bringing over a bunch of the additional, stop sending any of those extra pieces. And so I think that's where you start ending up having to dig deeper into the H2 stack than you do to simply say, hey, be okay with these extra frames and it's fine.
I just want to add, like, if we change, again, if the resource model turns out to be different, it's just, again, another reason why reusing H2 native things are not useful.
Yeah. Cool. It sounds like we're getting, and Mike, is that something you'd like to say at the microphone? Because I think it's something I was also wondering.
So basically, I was just observing that given that H2 is an in-order reliable byte stream, no matter how you spell it, I would not expect a performance difference by using native capabilities versus just doing it as capsules inside the body of the Connect. Whereas in H3, by moving it to different streams and datagram frames, you actually are getting performance differences. You're getting concrete differences in behavior in the transport layer.
Yeah,
that doesn't seem to justify changes in H2.
Yeah. I see Martin's in the queue. Sorry if I skipped you.
Talk about the resource thing, but just to Mike's point here, there is a little bit of an overhead if you don't use the native frames. But the difference is interesting because the data frame has a 5-byte header that you can amortize over multiple capsules. If you use independent frames, then all of your frames will have a fixed 5-byte overhead, which might be bigger than the overhead you have for an individual capsule because of the way that the encoding is more efficient. So there's a little bit of a difference there, but it's not like enough to worry about, I don't think. To Alan's point on the resource management thing, I've sort of come to realize that I don't think this is going to inform our decision very much because of the way that we've approached the resource management issue generally, which is to say that it looks like we're just going to dump the simplest possible resource management on top of this, and in H3 we're going to have the streams sharing with all of the HTTP requests, and we'll just sort of let people deal with it. Is where that sort of ended up, and that's not terrible. So I think the predominant decision-making points here are the ones that Eric went over just now. Unfortunately, because I think the resource management thing would very much decide it in one way, but I don't think it's going to change this one.
Seems reasonable. Alan?
Yeah, I just wanted to talk about performance for a second, which is that it's not so much the wire overhead, particularly when you're thinking about in DC use cases. The performance profile of the applications that can use this can look very different. And things like the fact that you'll have 2 hash table lookups, one in the sort of outer stream and then one in your sort of list of inner streams, that kind of thing will definitely show up when you're doing like high RPS, RPC use cases. Or other types of DC use cases that may be leveraging this. So I just want to, there could be a performance impact, but again, my read is no one cares. Everybody is just like done with touching H2. So
that's a performance difference that is mitigated by breaking it out to use the H2 native capabilities, right? Not necessarily a reason to go bolt it into H2 itself.
I guess, yeah, if you could say like use the H2 native, build an extension that uses those capabilities if this is holding you back performance-wise is an option there, yeah.
That was kind of thinking. Ian?
On the performance question, if we think 95+% of people are hoping to use the quick-based option, I mean, how much do we care about performance as long as it's like acceptable? I agree that like the more layers you have, the harder it is to optimize performance, but that's actually already a problem for us with HTTP2 today. Like I think we've actually gotten to the point where our H2 stack is typically slower than our H3 stack because our H3 stack is like more tightly integrated, and our H2 stack goes over TLS and has an extra record layer and like all of that stuff. So I guess I feel like if you want performance, probably web transport over H1 is actually the ideal option, and you should just like not even support H2 for ALPN. And as probably all of you know, that's what YouTube video servers do. So,
which is actually an interesting point there, because when you talk about kind of the 95 and 5% of users, I think the data center use case was one of those where we weren't saying it's going to be some small subset of users. It's for, within my data center, I want to do this always. But at that point, I can also completely control it and choose to do it over H1 if I'm concerned there. So. All right. So I think we have pretty strong support for moving to a more layered approach where the layers are a little bit more independent. I suspect that we'll be chatting about this on the list and in some of the GitHub issues. So please, come make your opinions known there. We have one more thing to chat about briefly, which is another kind of existential question, which is connect. And so as we've been talking about kind of how we do these different things and how do we integrate with Mask and how do we handle all of that, we said, well, there's significant overlap in participant group between these two different working groups, but it's a little odd that we ended up using different approaches to how we handle connect. And so Web Transport is using extended connect with a protocol value of Web Transport. And in Mask, connect UDP is a new method rather than extended connect with a protocol of value UDP, and similar for IP. And I think both working groups so far have kind of laid out some reasoning for we want to use extended connect here, and we want to mint a new method over here, and these are the different properties of new HTTP methods, and connect is potentially icky, or we like extended connect because it provides these other properties. So I don't know that we necessarily need to make a huge change necessarily, but I think it's worth bringing up. I think it's worth talking about. And I think making sure that we've written down our rationale for why did these end up different? Why are we not using the same approach? If we've said this is the way to extend or do more things with Connect, what is the way that we should do this? Is this something that we should talk about in HTTP Biz? What's the right way to do this? Because it seems a little weird that we did two different ones. If we have strong reasoning for it, great, but we should at least write that strong reasoning down. Thoughts and feelings, Martin?
Based on the discussion we've had, and I don't know if Kazuho is here, but Kazuho had a couple of good points about Connect versus new methods. Based on that discussion, I'm sort of leaning slightly more towards extended Connect, using the colon protocol field to indicate which one of the protocols that we're talking. The only thing that I genuinely care about is that we're able to use an HTTPS resource URL that identifies the resource that we're talking to, rather than the thing that you're connecting the IP tunnel or the UDP tunnel or the TCP tunnel to, which is the old Connect semantics. And as long as we have that, which all of these options provide, then I'm happy. So I think we should just pick one, and we should probably pick one for all of the things that we're doing, and only use that one. But I don't actually mind too much beyond that.
Makes sense. David?
Yeah, so I agree with what T was saying. I'm going to bring this to the mask list to say, hey, it seems like there are these arguments there, and if folks agree there, then we can probably have mask unify on what WebTransport is doing and then call it a day. That sounds like the simplest option to me. But I'll bring it over to the mask list, see what folks think over there.
Thank you. Victor?
The initial reason we used Extended Connect is that it's consistent with what WebSocket over H2 does, and Extended Connect is a good way of representing resources, which are real resources, but do not necessarily fit into the regular HTTP semantics, which is exactly what WebTransport is. So I believe, at least for WebTransport, we should stick to Extended Connect. I have no opinion on what Mask Working Group would want to do.
Lucas?
Yeah, like having played around with some of the stuff for Mask and a bit of WebTransport, although that I got stale. I just call these things Connect streams anyway, regardless of the method that they are, and that's like the easiest way to explain it to anyone else who isn't on these meetings. It's just Connect thing. So I would be in support of Connect method with a pseudo header.
Sounds good, Martin.
So I know that certain people have something of an allergic reaction to Extended Connect and RFC 8441, and those people aren't here. So I would suggest we take this to the HTTP Biz working group as well, and we'll make sure that those people have their input on the discussion as well. I think we're headed in the right direction, but I want to make sure that we don't create any surprises there.
That sounds good. We did a very similar thing for some of the datagram stuff between Mask and HTTP and WebTransport. So I suspect we can have similar here.
Yeah, I'm jumping in as chair, wanted to confirm that we'll definitely be discussing this on all three lists to make sure everyone's aware and we get input from the community at large.
Awesome. Thank you all. This has been, I see Mike is in the queue.
But wasn't Extended Connect experimental? Because if it is and Web Transport is not planning on being experimental, that may require some manipulation at least.
As
Makes
far
a
as
lot
I
of sense.
can look at standards track.
Weird.
RC8441 is the one that defined this, and it's standards track.
Excellent. Okay.
Even
Thanks for
better.
checking. That would have been kind of a sad thing to notice in ISU review.
All right. Thank you. This has been super helpful. Thank you all.
Right. How do I? There we go. Check slides again. All right. So it sounds like we made some really good progress today. We fixed a bunch of issues on H3. Sorry we didn't get around to that go away one. Hopefully, I mean, from Victor, it sounded like this one would require more discussion that wouldn't fit into this meeting anyway. And on the topic of what we want to do around TCP, we're getting a sense from the room that folks are kind of unifying on building on top of HTTP semantics. So we're gonna confirm that on the list, but since we have some time left, if anyone were to disagree with this direction of building over HTTP semantics and then having HTTP version specific optimizations like in H3, the datagram frame, could they come speak up now? Otherwise, we're going to assume consensus in the room and validate it on the list over the next couple of weeks. So I'm going to pause here for a second. Okay.
Not seeing
so
anyone in the queue.
Yep. So we're gonna assume consensus in the room. And I guess that's a wrap. Anything you want to say, Bernard, before?
Oh, well, just a question about whether we should be planning an interim or not. We have enough things to do there.
My gut feeling would be let's have the web transport over TCP enthusiasts kind of maybe huddle in terms of seeing what they want to propose, and then discuss that on the list. And then based on how that goes, we can see if we want to have another interim. And similarly for the web transport over HTTP3 issues, if anything gets stuck, we can have an interim to discuss them. But let's see how things go on the list first. Alan, you had something you wanted to say?
Yeah, not so much an interim, but I wonder if maybe holding a virtual interop sometime between now and the next meeting would be useful. It seems like there's a few people with H3 implementations, or just setting aside a time where people would have a target to work on it might help move that ball forward.
That sounds like a good idea.
Yeah.
Cool. We'll also try to set that up as well. Great. I think in that case, we are done with 7 minutes to spare. Hooray. Thanks everyone for coming, and we'll see you on the list and on GitHub pretty soon.
Thank you.
Bye.